Okay, now before we get into exponential derivatives, I would like to review how we solve some equations here. Just as a review. No. No. Is the base to the exponent by itself?
No.
E to the 3x minus 2 equals 3/4. Now, how do we rewrite this? I don't know. I was believing someone over here. Okay, it's natural log of 2/3 equals e to the 3x minus 2. Nope. Sorry. Log base e of 2/3 equals 3x minus 2. So how would we solve this?
That's one funky thing.
Nope, this is just an algebra problem now. Can you put this in your calculator?
Oh, yes.
And then add 2? And then divide by 3? Right? So what's x? This is just some algebra. Algebra 2 here.
0.532.
Okay. Let's talk about this one. How would we solve this one?
E to the 17.
Subtract 13 over first. Then divide by the negative. Now that the natural log is by itself, we rewrite it as okay. Now, why does it work like this? Okay, the natural log of x and e to the x are inverses of each other. So when we have the natural log of e to the x, it's really just x, because that's an inverse inside of, it's the function inside of its own inverse. Okay, e raised to the natural log power, or of x power, is just x, because we have a function inside of its inverse, right? This stuff you talked about in Algebra 2 and in pre-calculus, correct? Okay. Please remember this. This will be helpful. Okay. Now, what I want you to do, don't give it away. Okay. You're going to make a discovery for me. Okay. So I want everybody in your calculator to graph. Well, I guess you don't have to graph it. I don't care how you do this. What I want you to do, you can either graph it or you can do it just on your home screen. I want you to find f of 0 and f prime of 0, f of 2 and f prime of 2, and maybe pick another one if you want. Okay. What's e to the 0?
1.
Jimmy, do you know what the derivative is at 0? Is it? You got 1 for the derivative?
No, derivative. I got 0.
my calculator's not up. Practice
I
your
got
derivatives,
one.
people. You got one?
Yeah.
Whether on the graph or on the home screen, practice your derivatives. Like,
Second for math.
yeah, you can do
Oh, okay.
derivatives on Math 8. Either Math 8 or on your,
So it's n derived of the function comma x comma 1.
if you want to evaluate it at 1. If you want to evaluate it at 2, you would want comma 2.
Okay.
It's the same thing.
It's 1 for all of them?
No, I mean like, if it's like, since I think 2 is 7.38, the derivative is 7.38.
Oh, the derivative is also 7.38.
How do you calculate that last one?
Math 8. So then you have e to the x, comma x.
It's easy.
Okay, you press it here.
Which is for like x equals 2.
Oh, you close the parentheses.
Zero.
Uh-huh. Because that whole parentheses needs the comma x, comma 1.
Oh.
Okay? What's e to the 4th? That's something. And what's the derivative at 4? Okay. Are you ready for the easiest derivative in the world? What's the derivative of e to the x?
Yes. My only question is why?
I will show you why. I'll show you why. Okay, so I'm going to go through a quick 3-step proof, maybe 4 steps, on why e to the x has a derivative of e to the x. You don't need to write this down. I'm going to just show you why. And then we're going to go through some examples. Okay? So, y equals e to the x. What I'm going to do is some logarithmic differentiation. Natural log of y equals natural log of e to the x. What's the natural log of e to the x? Right? Natural log and e are inverses, so we're just left with x. Now, if I take the derivative of both sides, what's the derivative of this left side? 1 over y, dy dx equals 1, because we're taking the derivative. So dy dx equals y. And y is e to the x. Okay. So there's your proof. I know why, whether you care or not. Okay. As a reminder, okay, this wouldn't be necessary to write down unless you really want to, but just remember, if we have a function inside, we would have to do the chain rule. So the derivative of e to a power is e to that power, and then you would have to do the chain rule. Okay. So I kind of like to view this derivative as copy-paste. Okay, e to the x, the derivative is e to the x, copy-paste. Okay. If there's something inside of your power, copy-paste and chain rule. Okay. Are you ready for some examples?
I get example.
I'm really proud of that. Okay. The derivative of e to the 2x would be e to the 2x times 2. Okay? Well, since the derivative of e to the x is e to the x, okay, we copy paste for the derivative, and then we have to take the chain rule. The derivative of what's inside is 2.
Oh.
Yes? e to the 2.
Oh, you have to,
Okay, so our derivative is, first of all, it's e to a power, so e to the power. Now, chain rule, what's inside? Now, what?
No, 2 times x to the negative 1.
This is the same thing as 2x to the negative 1. And so how do we take that derivative?
Negative 2x to the negative 6.
So we have negative 2 e to the 2 over x squared is how you could rewrite that. If you view 2 over x as 2 times x to the negative 1, then we can do the power rule for its derivative. We do the chain rule.
so it's just a constant.
What do we have? We have a product. Look at how good you guys are at recognizing that now. All right. Product rule. Derivative of the first times the second plus the first times, we need to take the derivative of e to the x squared. So the derivative of e to the x squared would first of all be e to the x squared times chain rule, 2x. So what we have is, okay, you can write it like this. You can factor out an e to the x squared. That would be fine. It does not bother me either way. Okay. Well, I think I'm going to skip this one. Is that okay?
This is another example.
This is another example.
Oh, is that all on the top?
Yeah, that's all in the exponent. So when we take the derivative, e to the 2x squared plus x minus 1, and then what are we going to have to do with that? I bet there will be a problem very similar to that on tomorrow's quiz, so make sure you can do it.
Is that like wink wink hints or?
I'm telling you know how to do that one. No hints.
She recorded it, so that means too.
All right. Now, what if we have a power to a base, well, that the base is not e, right? 2 to the x, 3 to the x, 4 to the x, okay? So, I'll just tell you what it is right now, and then I'll show you why. How's that? I think you guys like it better that way. The derivative of a to the x is a to the x times the natural log of a. So it's still the copy paste, but we need the natural log of the base. Very similar to how we did logs yesterday, right? Okay. If the base isn't e, whether it's a logarithm or an exponential function, we need the natural log of the base. writing messages. Okay, so I'm gonna go through why it's this derivative. You don't have to write this down, you don't have to care, but I'm gonna show you why. Okay, so do you agree with what I have written here?
Yeah.
Okay.
Yes. Okay, well, first of all, this would be like if you think of x times natural log of a, right? So this would be e to the natural log of a to the x. And those would cancel and just be a to the x. Okay? So, since we know the derivative of e to the x, okay, I can show you what the derivative would be if I write it like this. Do you see what I'm saying there? Okay, so if we take the derivative of e to the natural log of a times x, we get e to the natural log of a times x times the derivative of what's inside is the natural log of a.
What do you want to
Wouldn't you still need to use particle? Because you have x.
Natural log of a is a constant, because a is a number.
Oh.
A is a number. A is a number.
That's right.
Okay?
I just have one question.
Yes.
What would happen if you had something like this? Because you, like, ignoring this, what would you do with something like this, and you just have plus one? You took parentheses off and you have a plus one right there.
Well, we would still take the derivative the same. It would still be the derivative of e to the whatever power times the chain rule.
Okay? Okay.
Okay. So these cancel. We're left with a to the x times natural log of a. Okay, that's why if you care, if you just want to remember the rule, remember the rule. Right?
Right.
Let's practice.
Yep.
The derivative of 3 to the x is okay, copy paste 3 to the x since the base is an e, natural log of 3. How about 3 to the 3x? Okay, so first of all, copy paste times the natural log of 3 times chain rule. Okay, so we have 3 natural log of 3, 3 to the 3x. You could leave it like that. Could you rewrite your answer a different way?
So you want to multiply the 3 and the other 3?
Wait, which 3 are we talking about?
If you wanted to combine these two, it'd be 3 to the 3x plus 1 power. Because when you multiply, you add your exponent.
Not this.
Leave it like that. Okay. A few more quick examples.
Thank you. That was John. Why are you looking at me? I said thank you.
What's our derivative? Derivative of 3 to the x. What rule do we have to use for this one? This is a power rule problem because we have an x to constant.
I saw it, I was like,
This is, e is a number, right? So like how do we take the derivative of x squared? 2x to the first power. Okay. I just want you to understand the difference between this first one and this third one. Okay? How about the first third to the fourth one? Can we do the power rule?
This one right here.
maybe.
No, it's not constant.
Okay? No. Is our base a numerical value? No.
It doesn't exist.
What we would have to do
Some smart dude came up with
is logarithmic differentiation so that we can write it
Oh, wait. 8.
like this. Mm-hmm. Mm-hmm.
Do we like have to like do something like this with the logarithm, whatever you just said?
the quiz.
A problem like this will not be on the quiz tomorrow. Okay, but could you do it?
Almost.
Well, I'm saying, could we continue with this?
Oh,
What
yeah.
would it
Yeah.
be? Yeah, right? We could do that.
X squared and
So then you take the derivative of that?
Well, yeah, let's do it for practice.
Because logarithmic differentiation could be something you see tomorrow, right?
Hopefully not, but
Okay,
it could be.
derivative of natural log of what? How do we take the derivative here? Product rule, derivative of the first times the second plus the first derivative of the second. So 1 over y dy dx is the natural log of x plus 1, which means we need to multiply the y over. So dy dx is y times that.
It's the X value of natural language.
Okay, because on the homework, that's the part where I got confused. So once I got to that part, I got no idea.
Okay, okay, so why did I have this slide? I want you to understand the difference between the power rule and our exponent rules. Okay, the difference is very important.
So when do we know that we need to use ln on both sides?
Well, I guess in this case, if your variable is both your base and your power, you would have to then. Otherwise, if you have like a big complicated mess of a quotient, that would be a time to do it. On tomorrow's quiz, I will tell you, please use logarithmic differentiation for this one. And you wouldn't want to do it any other way on the one I'm going to give you tomorrow. Do you have a question?
Yeah, so basically what you're saying is that you can only use your rules if there's a constant. That's basically
Well,
what that means right there. And then-
Power rule needs to be a variable to a constant power. For these rules, we have a constant to a variable power.
Yeah, so in other words, there must be a constant.
Well, in each of these rules, we have a constant somewhere, yes.
And you also must have at least one variable. So, is that not your
I mean, these are just each separate rules within themselves. We're just comparing them all together.
Okay?
2 quick examples and then we're done.
It's only Thursday.
Oh.
Yeah.
So this first one, we have h to a power. What's the derivative of h to a power?
log of 8 times.
Natural log of 8, copy paste. Okay,
How would you know to use that? Is that because
we have a number
And
to a
then
power with a variable in it.
Do you have to times that by the?
cosine of
Yes, we need to talk times by the cosine of x for our chain rule.
So it's basically L natural log of A times A with x times the derivative of x.
If you want to think of it like that. Last one. Five to the 3x. Natural log of 5. Copy paste times 3. So 3 natural log of 5 times 5 to 3x. If you wrote it like this, it'd be fine.
Alright, so what's on the quiz tomorrow?
Tomorrow's quiz is going to look like this. Implicit differentiation.
and there's a y.
When there's x's and y's all together and you have them, okay? Like that half sheet of paper, right? Log derivatives. Exponential derivatives. Obviously, power, product, quotient, chain rules still all apply. I guess I should put in here logarithmic differentiation will be on there.
Will there be, there'll probably be a change of base ones too, right?
What do you mean?
Like,
Like a log base naughty. So you need to be able to do exponential and logarithms for base E and base A. It should be a shorter quiz. Okay, I'm anticipating it taking 30 to 40 minutes. Okay. And so there will be maybe 5 minutes to where if you have questions on tonight's homework, we can go over, 5-7 minutes worth of something and then get started on it. Okay, I'm not going to give you a review because you've had some homework problems. I don't want to pile on more, really. And so use your homework as a guide. Do tonight's homework. Go back and look through the previous night's homework. But it's all been kind of building on each other. Today we practiced logarithmic differentiation already. We practiced some implicit differentiation. Okay? This is your homework.